Hi, everyone. Thanks for joining us. I believe we're now streaming. Welcome to the Data Plus AI online meetup. We're super excited to have you here. I am just going to start the presentation. I have just a few quick slides before we get to all of the good stuff. All right, so my name is Karen Bizaturlo, and that is a picture of me. I love photo booths, and so that's the first thing I looked for when I went onto the Summit platform, is to check out the fun photo booth. So I encourage all of you to visit it as well. It's a fun little addition there. And I also wanted to put my email address first and foremost. I run community programs, and we have a online meetup group that we're always looking for different community talks and folks to speak there. So please email me if you have any suggestions or you'd like to give a talk. Not many people email me, so this is a call out. So I'm putting it up there. So I'd love to hear your suggestions and hear from you. So great. So thanks for joining us. This is the Data Plus AI online meetup. Apache Spark 3.0 internals and building structured streaming microservice architecture. We have some really amazing speakers for you here today. We have Scott from Twilio, Jessic, who's an independent consultant, and we have the famous duo Jules and Denny, who are my teammates on the developer relations team here at Databricks. So they're gonna host the session and kick things off when I'm done with my intro slides. Again, so this is just a call out to the Data Plus AI online meetup group that we have. There's the link above. I'd love for you all to join. We have a lot of great sessions, a lot of awesome technical content, AMAs, lots of different sessions in there. And again, if you're interested in giving a talk, please reach out, message me through the platform. We'd love to hear from you. We're always looking to engage more with the community and highlight the projects that you're working on. This is our meetup for today. We also have one at the end of the conference tomorrow. So just a quick shout out for that session as well. We have Oliver and Andre joining us for that session, as well as Jules and Denny. Another really cool feature about the conference platform that I wanted to call out is if you go in and check out the Dev Hub plus Expo, scroll down a little bit and there's a section called Hallway Chatter. So these are going to be kind of topical based chat rooms that you can go in and ask questions and interact with other attendees. It's a really great way to kind of, be a little bit more interactive, ask questions. There's also a few live lightning talks that we're running. We already ran 2 today. We asked the community to submit different projects they're working on and have them present lightning talks. So you can find the lightning talks in the summit agenda and also in a few of those chat rooms. So I'll leave it up to you to kind of click through those and check out what's in there and see what live sessions we have available for you. And right before, or just before I kick it off to Jules and Denny, I want to let you know that this meetup is recorded, and so this will be available on demand pretty shortly. I mean, we'll make sure to share all the resources and everything with you. So in case you have to jump off early or you'd like to revisit the session at a later date, you're more than welcome to. So with that, I'm going to pass it off to my colleagues, Jules and Denny.
Hello, Denny. Hello, Karen. Hello, Jules. I'm speaking in third person, Frank.
Again?
No. How are you guys? What happened to Scott? He disappeared.
Do we lose Scott?
No, he's here. Okay. He's here.
No, he's here. Cool. I guess we're supposed to actually be talking about Data and AI Summit. I believe that was the context here, my friend.
Well, I've been awake since 3 a.m. in the morning, and I have been drinking loads and loads of coffee. And I think one of the things that is justifiable for us to do is to hand out these little mugs as part of the swag to only people who get up 3 a.m. in the morning and host sessions. So I think Danny, you're going to take the responsibility to make sure that we get these tumblers with Data Plus AI Summit. What do you think?
Sure, let's go with that. but I
And,
don't think that,
and welcome to all of you guys, whatever time zone you are on. I'm really excited to be here. You can't see anything below my waist because I'm levitating with joy and excitement. I've been drinking a lot of coffee, so I'm in an altered state of mind. And I can't be more happy to be with Karen and Danny, my esteemed college mate, and one of the very outspoken people in the Spark community. So I'm delighted to be here. So Danny, how was the session this morning? I mean, what are you really excited about today? Or given that we have gone through all the keynotes and now we are towards the end of the day. And I think one thing we might want to ask the community, how many of the people right now are sitting in the living room because lockdown in Europe, are not drinking coffee, but they have something else that they're drinking? What do you think? Karen, you wanna shout out to people to put something on the chat channel to see what they're drinking? Because normally when we host these happy hours, Danny, we always have a happy hour before the meetup, don't we?
that's true. And you know what? I'm actually chiming in right now. What are you drinking? Of course, Scott is with his peppermint tea, but
what is Yazik drinking?
yeah, Jacek, what are you drinking, my friend?
Hold on. Well, this is a very good, fine Japanese tea, bancha, by the way. So it's exactly for my taste at night or before I go to bed. Wait, by the way, I'm in Europe, by the way, guys. So it's 7:06, so it's pretty late, or it's getting late and late. So I'm preparing myself for good sleep.
Ah, okay. Well, no, that makes sense. See, we have some good people here that I think would have gotten along well together if we went ahead and actually had these sessions face to face. Because originally this was going to be in Berlin, so we're all going like, man, we could have had like kegs of beer. Like, just, it would have been awesome. And so, but then let's see, we got some people chiming in. We got a Long Island iced tea from somebody from Kyle from the University of Cape Town. So that's not too shabby. I used to drink far too many of those in my life.
Ooh.
And then, hey, cooking dinner, drinking whiskey. So I'm presuming, Theodoros, that you're drinking whiskey and cooking dinner as opposed to cooking dinner specifically. You're cooking dinner with whiskey, because if you are, that's a no-no. I just want to be very clear about that. That seems wrong on so many ways. Okay, so, but yeah, so fair enough. Okay, we got coffee, water, a bit early for beer, sadly. No, David, it's 5 o'clock somewhere. It's never too early to drink. Okay, so let's be very clear here. Okay, so what else do we have?
We have somebody. We have somebody who actually commented, "Learning Spark 2.0 is actually a good book." Well, here's the book.
Oh, yes.
I'm with my esteemed co-author, Denny, and one of the reviewers is here, Jacek, who gave us incredible good feedback, and we're actually happy to have this book published finally.
Exactly, right here. There you go. Bam, bam.
Right here.
Of course. Now, of course, that was not an attempt on our parts to shamelessly plug our book, was it?
Well, it wasn't. It was Said Khalid who actually said "Learning Spark" is a very good book.
Okay, so we did not plan that.
No, I wasn't planning on this. Okay. I wasn't planning on this, and
even though we had our books handy with us.
Yeah. Absolutely.
Okay, good. Just want to call that out. All right.
And obviously, Jacek's Learning Spark is a good thing. Now, Denny, I mean, the keynotes were exciting today. I couldn't be more excited about the way Ali actually set the tone. And I think one thing that really resonated with me was when Ali said, there has never been a better time to address the world's data problems than today, right? This is our time. And it was quite fitting because it actually set the context for the entire sessions of keynote. It set the context for how we actually providing a single platform to bring all the data teams together. You got SQL analysts, you got data scientists and machine learning, and you got BI reporters. Single platform to be able to do that. And underneath, Renaud talked about the photon, how we actually provide that. And everything was insightful, was instructive, especially when Renaud talked about, when you think about performance, you think about in 3 dimensions, right? You think about concurrency, which is number of people who are making the connections. You think about latency, which is not how long it actually took, but the latency accumulation of not only response time, but how long it actually took for the query to execute. And then finally, what was the throughput? And I wasn't thinking in those terms when I thought about performance in those 3 dimensions. But now the fact that we are actually providing, or the world is providing data as a service or providing a software as a service, in the cloud, you begin to think in those 3 dimensions. That was actually quite insightful for me. And then obviously, you know, with the keynotes from both Reynold and talking to Bones, and also Malcolm actually sort of closed the whole thing that talked about how do you actually frame problems in 3 different ways: framing, you know, usefulness, and courage. And it was actually quite interesting because he talked about data in the same way that we are trying to address data problems of the world. What do you think about, you know, what was your takeaway? And I know you had a close Q&A session with him, and that was quite insightful the way he was answering questions. Could you share that with some of us?
Oh, absolutely. No, it's a great call out. Let's start with Malcolm first, because Malcolm Gladwell, if you all don't know, he's a well-acclaimed author, 5-time New York Times bestseller list. His latest book is Talking to Strangers. And Blink is another book of his book, Data and Goliath. That's a very good book. That's my favorite book. Keep showing that, Jules. Outliers. That's easily my favorite book of the bunch. But by the same token, they're all very good books. If you also want to listen to him, I highly, highly recommend Revisionist History. It is a great podcast series created by himself and various other folks. He's really making audiobooks not just about the spoken word, but actually integrating other audio components to make it really interesting to listen to. And so highly recommend. The Q&A was very insightful, even though it was only for 30 minutes. My compatriot Brooke and myself were fortunate enough to ask him a bunch of really cool questions, and she happens to also be one of the co-authors of the Learning Spark book as well. And what was interesting is that it all came down to the ability to storytell. Mm-hmm. Right, that ability to we as data engineers or data scientists or data analysts, doesn't matter, right? We're all very good at looking at the data and trying to make sense out of it. But what we often are horrible at doing is to be able to provide a solid enough narrative so people can actually understand what we're talking about.
Right. Absolutely. I mean, spot on. You know, data without context is completely useless. And I think that he sort of gave us the framing and the context of that. What are some of the, I haven't had a chance to look at some of the sessions, but what I did instead, and I know I was going to say, you know, select a couple of sessions and recommend that, but I thought about that. I said, it's like asking a botanist to go to a bountiful Victoria, beautiful garden in Ireland or Vancouver, beside Victoria, and pick up the best flower. It's almost impossible, right? And so it's like, you know, each and every flower has its own utility. Each and every flower has its own pollen, and every insect will be attracted to the flower because of what it actually provides. So instead, what I did was Cheryl and I went through and collected a list of favorite talks that we thought resonated with us, because we are the insects who get attracted to those flowers. And we put together a list of, you know, here are some of the MLflow and machine learning talks that you might want to do that. And I'm going to put that list as my favorite chat talks that you actually might want to attend in the chat. So let's see if that can, there you go. So if you are interested in machine learning talks, and if you're interested in MLflow, those are actually some of my recommendations that I put together along with Cheryl to find out, you know, what really excites you. So I think those were the 3 things. And obviously all the talks about koalas, all the talk about Apache Spark 3.0, all the talks about lakehouse. So there's a bountiful, and there's one person in this chat room today, his name is Jacek. You know what he does? After the summit is over, he goes through each and every talk, reads about it, tweets about it, goes to the source, goes to the Scala source to say, today I learned about, you know, blocking cache, and here how it works. And then he includes that in his book. I mean, this is what I'm going to do. I'm going to binge like Jacek, forget about Netflix today, forget about Hulu today, forget about, although The Crown is on and I started watching it, but I'm not going to watch it anymore. I'm going to be binging it for the next 3 days. My weekend is going to be nothing but all this incredible content that the community has actually put together. So that's my, that's my end of the Brew Talk for me, at least. Excited about the summit, looking forward for tomorrow, all the talks that we have published, and we have 2 great speakers with us. Danny, your turn.
Perfect. Well, I cannot remotely compete with that amount of enthusiasm, but allow me to chime in with a couple of notes before we do shift it over to our acclaimed speakers. The first is since Jules had to do a call out to his favorite show, I do want to do a quick call out to Queen's Gambit on Netflix. Mwah, wonderful show. Number one.
Absolutely. Got to watch that.
Absolutely. Number two, I do not have a nice, formal, clean list that Jules is so organized of, but I did want to call out 2 sessions from today and 2 sessions for tomorrow. Okay. I'll put them in the chat afterwards as well. But the first one is with Franco Patano, common strategies for improving performance on your Delta Lakehouse. And then if you're wondering why Photon is interesting, right? Because and you're going to love the naming convention. Photon is a polymorphic vectorized engine written in C++. Now, then you're going to ask, what's polymorphic? Why do I care about vectorized? And why in God's name do I care about C++? Now, we could literally take the next hour and a half to go and explain all of that, except that's not the purpose of this particular episode, number one. And number two, even better, Alex Beam, he knows that stuff really well. So he actually had a session called Photon Technical Deep Dive, How to Think Vectorized. Highly advise you guys to check that session out. And then for tomorrow, my British compatriot, Simon Whiteley, he and I, we do these regular tech talks a la Karen. Karen would just look at us bewildered. Why in God's name are these people talking? But nevertheless, we do. He has a wonderful session tomorrow called Achieving Lakehouse Models with Spark 3.0. So yes, don't forget, we absolutely love Spark 3.0. And then of course, my buddy Todd Greenstein, he has a session called Radical Speed for your SQL queries with Delta Engine. And it's all about how fast Photon works. So highly advise you guys checking that out. I'll drop the sessions inside the chat after this, but I think that covers for me today. Karen, I think it's time for us to probably shift to the main attraction so the poor people here don't have to continue listening to us.
Yes, let's do that. So why don't you introduce Jacek?
Oh, sorry, my bad. Is it Scott first or Jacek first, actually?
Jacek is going first, given that he's in Poland. And
right. See, I should actually read my email, shouldn't I? Okay, my bad. Okay,
that's all right.
Then, okay,
this is all impromptu. This is just a go as you.
Oh no, we planned this entire conversation. Yes.
To the last second, right?
Yeah, absolutely. Yes. Okay. Without further ado, let's also have Jacek speak. Now, before Jacek goes ahead and speaks, I did want to call out that his book, Spark Internals, is easily one of the most referenced online book of parts on Apache Spark, including those of us who have been working on Apache Spark for many years. We all refer to his books because exactly what Jules called out. He goes ahead, rips through the Scala code, and asks us tons and tons of questions. And if it wasn't for the fact those questions are amazingly good, we'd probably kill them. But instead, they're amazingly good, and we realize, oh wow, we wrote some bad code. So yes. So without further ado, Jacek, why don't you go ahead and talk your talk and kick me out of this session right now, my friend.
Thank you so much, Danny. Thank you, Jules, for this great shout out. By the way, guys, you know that I'm asking these questions about English language and how it evolves over time, and I'm very lucky to be working with you and be able to ask questions about how to use English properly. And one thing I noticed, it was kind of like 1 year ago when I first heard this phrasal verb. This is especially, special phrasal verb. And by the way, we don't have phrasal verbs in Polish. And so one phrasal verb that stands out, all the time when you are speaking about something is call out. Call out seem to be used everywhere now these days. It's like you are calling out everywhere and anytime. It's like, because I'm picky at picking up special words, and how people are communicating these days. I just, if I were asked to vote for the most famous or most common used word in English these days, it'd certainly be call out. So thank you for calling me out. May I say it like this?
You're welcome.
Okay, thank you. So, okay, so gotcha. So Okay, so let me share my screen and let's kick the tires. Is this proper? Awesome. Okay, so share my screen. Share. And you should see my screen with this with my slides. Is this correct? Can you confirm
Yep.
that you see it? Because thank you. Okay, so okay, just yesterday I had another meetup. It was about Presto, and so I need to clean up my mind and think straight to the point about Delta Lake and success streaming. By the way, guys, you know, it was mentioned a few times during this intro that we technicians, you know, data analysts, data engineers, data blah blah blah, whatever you name it, you know, we are good at technology, but we are not very good at this narrative, you know, putting things in context. And I must admit, one thing that strikes me quite often is that, you know, even after 5+ years, almost exclusively with Apache Spark, you know, it does not stop surprising me. And what I'm gonna show you in a sec is exactly something that you know, surprised me a few days ago. And to my good surprise to say, it was like I couldn't explain why things work this way. And even when I, you know, deep dive into the code and notice that there is one join, another join, you know, it was not very clear why it happened. So what I'm about to share with you today or tonight, depending on your time zone, is what I found out about arbitrary stateful aggregation, and combined with merge into something that's brand new in Delta Lake, depending on the version you are using. And I've got some clients who still are on Delta Lake 05, to my great surprise. Not very pleasant experience, but anyway. So I'm digressing. So this merge into is available in Spark 3 plus Delta Lake 07. So this combo is what I wish I could spend most of my time with. It's not always possible, but anyway. Okay, so this is Delta Lake and Spark Success Streaming. It turned out that I don't have to think in streaming to understand the problem I'm trying to solve for my customer. And it turned out that it also happens in batch queries or with batch queries. So I simply shifted from streaming to batch, and yeah, and could focus on this particular problem. So what the problem is? Okay, so my customer called me couple of months ago and said, "Hey, I'm gonna pay you for dealing with this nasty problem." They called double metrics, and I was kind of surprised because I'm not very often with metrics when I'm working with Spark. I'm most often with, you know, high-level APIs or low-level or internals, but not much or not so often with metrics. But this particular case was about metrics. They plugged in their own metric system and started, you know, exploring what happens with streaming queries. And they found out that all the metrics are doubled when you use arbitrary stateful aggregation combined with merge into. So I started digging in, and this is what I found out. No, that's not what I found out. That's something I knew already. This is about myself, so I can just clearly say it with my eyes closed. So I'm Jacek Laskowski, and I'm IT freelancer specializing in Apache Spark, Delta Lake, Apache Kafka, and a bit of Kafka Streams, and lately Presto SQL. So if you need me for any you know, Spark related, Kafka related thing, ping me, Jacek Japila PL, or just DM me on Twitter, okay? And as you may have heard, my free time is no longer free because I'm obsessed. Yes, that's proper description of how I feel about my free time when I can sit in front of computer and look at the source code of Apache Spark, Delta Lake, and recently Presto. So all I can find, putting as notes, some people call it books, available at this books YAPI. Okay, stop talking about me. You can find all the internals of Delta Lake by my eyes in this free online book available at this books YAPI Delta Lake internals. Okay, that's it. Okay, friendly reminder for whoever wanna ask questions, please do so. So should you have any questions, feel free to ask them in the chat window. We'll get to them after my and Scott's talks. Okay, so no worries. Your questions get answered at some point. Okay. Okay. So these were client requirements and recommendations. Okay. So my client called me. Shall I say called me out? No, call is okay. So he reached out to me. Oh, another very nice common phrasal verb, reach out. Very common these days, especially on LinkedIn. Everybody is reaching out to everybody. So this client reached out to me and asked me, hey, could you do me a favor and just focus on this problem? And this problem was like this. Okay, he framed this by giving me this 3 requirements on your left. So the client wants to load Kafka records at regular intervals. That begs for Spark Success Streaming. We assume that we are all here for Spark, and there was no question whether Spark is a viable, good option or not. It was just assumed that we are going to deal with this using Spark. Okay, so the obvious answer was go for Spark Success Streaming. He said, I'm for it. I'm using it. Okay, I've been using it. That's one of the three reasons why I'm calling you. Okay, second requirement. Okay, do requirement. So the client wants to do a stateful aggregation in a custom per group way. We could delve into details why a stateful aggregation and whether it makes sense or not. But hey, just believe me, with a client who calls you and needs answer right away, he's gonna pay for this service, but he has no much time waiting for you to have a conversation about whether stateful aggregation, arbitrary stateful aggregation, and by the way, whether Spark at all. Okay, so he needs answer right away. So he has been doing this arbitrary stateful aggregation. And yeah, well, I just figured he's been using key value grouped dataset flat map groups with state. That was the moment where my world a little bit shaked a little bit, if I may put it this way, because, well, it's not very often when people go straight to this very advanced operator, streaming operator in Spark Success Streaming, or I would also assume in any other streaming solutions, be it Flink or whatever. Okay, so it's very, very advanced. So I had not many customers who'd be dealing with or who'd be using this, and now I'm about to hear about problems with flat map groups with state. Wow. Okay, I was curious, as much as frightened that I might not be able to answer this or that question. Okay, and third recommendation requirement was that the client wanted to update a delta table. Nice, that was Spark Success Streaming with delta table with aggregation results. Okay, so I started exploring all the possible answers and came up with this merge into and data stream writer for each batch. It turned out there is no easy integration of Spark Success Streaming and Delta Lake for merge into, except using for each batch, which, by the way, was kind of like how to say, a backdoor. Yeah, it was kind of like a backdoor for systems that are not tightly integrated with Spark. What I would expect, sorry to say, it's data now. It's Data AI Summit, so I can more clearly say it. I was kind of surprised that Spark, together with all the people behind Spark Success Streaming and Delta Lake, doesn't provide better integration, and all this merge into is still part of this for each batch. Things may have changed, to be honest, because I just found out that there is a brand new writer interface. Not sure whether it's available for streaming, but definitely there is a brand new batch API for defining your batch batch writes in using this Fluent interface. And I'm not really sure whether there is merge into operator. I think there was. So could be that if this customer used Spark 3.0, I could have provided him with a better solution. But something I haven't said yet, the client, was on a custom Spark build provided by Cloudera. So even though it was 2.4.0 made by Cloudera, he could run this Spark on Java 11, to my surprise, because Java 11 was officially supported since Spark 3, to my understanding, to my knowledge. So as you can see, these three requirements plus custom Spark build made by Cloudera with Java 11 made me a little bit nervous about, how much I know about Spark. So that was the context I was in when I was facing a problem I haven't really sorted out yet. So I'm working on it, and I'm hoping that this meetup is gonna put me in touch with people who know more about this particular configuration and could just shed more light on things I'm not yet good at. Okay, so for those who are not very familiar with arbitrary stateful aggregation, it's just a fancy name for, by the way, I like it. It's a fancy name for key value group dataset and flat map groups with state operator. This operator is available only after you execute group by key, which, by the way, I used to say to my customer to avoid, because it deserializes all the objects that live outside JVM. And this is one of the reasons why Spark can handle so much load, so much data with such ease. So because of this tungsten project and keeping, using this unsafe based handle all the data outside JVM, we don't see, while using Spark, that frequent GCs, as well as memory consumption is kept at a reasonable level. So all this, just to say that when I saw flat map groups with state, I knew that we are dealing with a quite sophisticated operation, and combine this with Delta Lake, well, it might not necessarily be a very common use case. So I was not surprised hearing that there are some problems with this. Okay, so what is this flat map groups with state doing? It just allows you to access state for keys that are part of this batch, speaking about streaming queries, or batch or batches, depending whether we are thinking about batch or streaming queries. Okay, so the point is that you, programmer, can access some state that's internal to Spark in programmatic way. So, and this flat map, for people who are familiar with functional programming, especially Scala, you immediately know that, or you can just reason about about this operator that you can generate 0, 1, or multiple results, okay, or output or values. That's the purpose of the flat map. Now combining it with groups, with state, we've got this flat map groups with state. Woof. Okay, so I just borrowed this description from Javadoc, Scaladoc, to be precise. So for a static batch data set, in other words, for batch queries, this function will be invoked once per group. That makes sense. And it also makes sense to think about this flat map groups with state for streaming queries, that the function this operator will accept is going to be invoked for each and every group repeatedly in every trigger to update group state by this key that's available in this batch. Now I know that I should have a diagram to visualize what I'm saying, but hey, I don't have it, so sorry. So I'm pretty sure that you are eager to see the code that I've been dealing with, because when I was initially faced with this problem, my initial idea was not to go over the code of my customer, but rather to reproduce it in a smaller chunk. So not only can I run it on my local machine, but also I can use it as to support my my emails or requests, public requests, speaking to people who are developers of this particular piece of code in Apache Spark. So TD and Burak and the crew. So so I reach out to them, but before I did this, I wrote this code. So now I'm gonna show you this code. Okay, so this is my IntelliJ IDEA, by the way. So I removed all the clutter and left this editor. By the way, the recent version of IntelliJ IDEA lets you edit your project or project files as if you were using Atom or Visual Studio Code. Very nice. Haven't tried it, but I'm pretty sure that it looks kind of like this without all the noise outside behind this editor. So I'm in full screen, by the way. Let me go to appearance and presentation mode. Enter presentation mode. It's gonna be a bit bigger. Okay, so it's just basic Spark application. By the way, quite recently I had a project for another customer where I bravely started developing Spark applications using Extends APP. I knew that I should not be doing it because you should be creating this main function. But I said, well, I haven't ever seen any problems with Extends APP, so why not do this again? And as I started describing my case for another client, it turned out that well, values are instantiated in a different context. So without delving into Scala internals, let me say that avoid Extends APP, or you will face problems you won't be able to explain. Okay, so anyway. So just wanted to share it because that was kind of like a recent experience of mine. So I created the Spark, imported implicits, boilerplate, correct? So I created this case class input because I thought that it's gonna be used for this socket stream. Turned out I don't need this input stream. Input batch, kind of like this, is okay. So I created this sequence of 2 tuples or tuples and 1, 1, 1, 2. I cast it to input for the only purpose of using this group by key. Since I'm gonna use this group by key anyway, so I did not bother using case class in this S. Okay, so I created a session class, and this is the function. This is the gist of my problem. Okay, so without spending much time on it, because I don't have that much time. By the way, I should be finishing up now. Sorry for making longer. This is just checking whether this timeout, blah blah blah. Okay, it's on my GitHub, so you can just pull it and run it locally. So basically, I just group by key, yep, and apply this flat map groups with state using arbitrary output mode update. I didn't care much about it, and group state processing timeout. That's very important, and this function. Okay, this function is here. Okay, so what I noticed is that after this transformed, I wanted to use Delta Lake and merge all these transformed values, rows, with the latest version of this Delta table. So by using this Scala API for Delta table, for Delta Lake, I use this Delta table for path as existing, merge it with values from this transformed data frame by using this kind of like merge condition, kind of AKA join condition kind of, and when not matched, insert all rows, whereas if you found matches, just update them all. Okay, that's very basic. I'm pretty sure that many have seen it already. Okay, in Delta Lake tutorials. Okay, so what I found out is that when I run it, I just pressed Ctrl-Shift-R and started running it on Java 11. That's why you see these warnings. No worries about them. I'm using Spark 3.01 with Delta Lake 070 and the latest and greatest of SBT, if that matters. And as you can see, look at this. This is batch query. So what I would expect is to see just one state update func executed for key 1. It turned out that even for batch queries, I see 2, no earlier state. So you might be mistakenly you might be thinking mistakenly that you somehow process 2 batches, but that's not the point. That's not the case. We are dealing with just 1 batch. That means that if you are monitoring, number of executions of this arbitrary stateful aggregation, you immediately get 2 rather than 1. So now you know the problem. My client called me out for dealing with this and sorting it out, another phrasal verb, but I haven't figured it out what the problem is still. Okay, so I'm working on it. Now you know what I've been dealing with. So so that was the code. Okay, and Karen, how much time do I have? 5 minutes, 10 minutes?
We do 5 more minutes.
Oh, thank you. So I showed you the code, and I had the code. So now I had this, how to say, I was armored, if I might put it this way. I was, I had all I needed to talk to reach out to Spark developers openly without disclosing any code that I was not supposed to disclose because of NDA, because of contracts and blah, 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 all this legal stuff. So I reach out to Delta Lake people, community, and I just said like this. Okay, so I'm gonna do this. And I said, hey guys, I've been trying to pinpoint the root cause of these multiple executions of blah, blah, blah. Remember, I was in a state where I just figured how to demonstrate the problem, but I was not necessarily sure whether it's a problem of Delta Lake, Spark Success Streaming, or both. And by the way, I did not know for sure whether I'm framing the problem properly. So I wanted to give enough information, but not too much, not to, how to say, steer thinking in wrong direction. And knowing that TD and others on this mailing list are also developers of Spark Success Streaming, I hoped I get better, how to say, hints, okay? And I was not mistaken, because TD replied almost immediately, and I was very glad. So I described the problem, and I said that I initially thought that it only happens with streaming queries, but turns out it shows up with batch queries too. So small reproducible sample is available here, blah, blah, blah. So I asked this very basic question. So it seems, why are 3 no earlier state printed twice for the key 1? And well, how to nail it to ask proper people. And TD said something I really enjoyed. He was very nice to me, very kind, saying, merge does 2 passes on the source data. So the source data computation gets re-executed. Fine. One way to avoid this is to cache the source data and then uncache it after merge. And I said, oh my, that's exactly what my client was doing, but he was not happy because, well, he was doing something he thought he should not have in the first place. And that's what I said to TD. Shouldn't merge do that instead? Because, well, end users, developers, Spark Success Streaming / Delta Lake users should not be bothered with this low-level details, how merge into works under the covers, correct? You should not, how to say, work around problems, internal problems of one or the other commands. So why does merge not do this? I wanted to be very nice and kind to TD and others to just get better answer and simply be able to fix it, even if it meant to write code on my own or support this code on my own. And Danny, yes, our Danny, said something I thought I'm gonna share during this presentation, because that's exactly how I would be showing how merge into works under the covers. I think the issue with merge automatically doing this is because blah, 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 blah. Let's skip it. I leave it to you. Sorry, Danny. By the way, that's what I liked the most. As timing would have it, just published today is diving into Delta Lake DML internals. And this is very nice, by the way, write-up about something I've been dealing with at the time. And yes, by the way, I had watched this presentation of TD on one of the meetups before Danny pointed it out, another phrase over it, pointed it out. So DML internals, very good presentation, by the way. Takes 54 minutes, perhaps half an hour, but touches the exact things I needed at the time. Did I say that I watched it already? I just this article reminded me about this update, but also about this merge into. Hold on, where's merge? Oh, this is this merge. Okay, so read about this, but the point is, the gist of it is that merge is doing inner join between the target table and source table to select all files that have matches. This is the first step, while the other step, the other pass over my input data set is to do outer join. And there is this very nice diagram, a very nice slide that touches this perfectly. Okay, so review it. There's scan 1, scan 2. And you know what? That gave me this thought that made me thinking even more about this. Why, since we know we are going to do multiple passes over one single data set, Delta Lake does not caches this data frame, okay? Because the idiom in Spark, the obvious idiom that the performance improvement, many forgets, many recommends immediately is whenever you do multiple passes over a data set, well, cache it, and you may expect some performance improvement. Okay, some, and not always, and for this, it was just obvious choice, even if it was after, some kind of configuration option. It's not the way it works, okay? And by the way, just to show you shameless plug, this merge into is converted into merge into command, and I dug deeper into the code and found out that this source data to merge, a state with is created when this merge into command is, well, it's created, is given when this merge into command is created, fine, and it's used twice. And something that's not precise in this slide, something that I'm going to ask Danny to fix, if I may put it this way, is that it's not obvious whether it's going to be inner join or left anti-join. Okay, so sometimes it's inner join that's count in web UI. Sometimes it's left anti-join. Okay, so I'm working on figuring out in a better way, but know that there's definitely at least one join. Okay, in most cases it's going to be inner join, but it could also be left anti-join. Okay. Secondly, there is another pass, something that Danny mentioned in the slide, out join. And yes, he is correct. Well, it's not that obvious what kind of outer join is going to be. It might be right outer join or full outer join. Okay, so all in all, there are two passes over the same data. Okay, so you've got all. Yeah.
Jacek, so sorry to interrupt you, but I just want to make sure that we have enough time for our second presentation.
I'm finishing up. Just 1 minute.
Okay.
Thank you, Karen. Thank you, guys. Scott, I apologize for this. Okay, so possible way out, something that happened right before this meetup, kind of like, I was forced to think, more about this problem. And you know what? There's one case I haven't tried yet. One possible way out of this workaround, so call it a solution. I'm not sure whether I could call it a solution, but can we design this pipeline in a way that state is another delta table? In other words, rather than doing arbitrary stateful aggregation as part of this flat map groups with state, why not to do the join with another delta table together with this stream of records from Kafka that would basically be or resemble flat map groups with state. And now we are in fuller control of what's gonna happen next, right? I haven't tried it and I'm sharing it. You are the first to hear it. Might be that you will need it. I'm gonna just check it out later. That was something that was called out already. So yeah, I've been reading it a few times already. So thanks for making this book free of charge. And that's all, folks. Thank you. And well, on to you, Karen or Scott.
Thanks so much, Jacek. On to you, Jules and Scott.
Well, thank you very much, Jacek. There are a few questions that actually are on the Q&A, but what we will do is you can actually answer the questions while I introduce Scott, and then towards the end, after Scott is finished, we'll sort of have a joint Q&A so people can actually pose your question. So thanks a lot, Jacek. Great insight into things, and thanks for sharing with the Delta team for us to be able to actually resolve some of the merge issues that we have. And we have very responsive developers on the mailing list that responds very quickly to these very probing questions that actually reveal a lot of things that we should do it to simplify things. Now, our next speaker, equally on the Spark front, has been an old friend of mine, Scott. He's been sort of an advocate of Spark, not only in the community, but also at the company that is working on Twilio. He's a principal software engineer over there, and he's sort of leading the efforts and leading Twilio into how do you actually build streaming microservice architecture. And so he's here to actually tell us about what are some of the things he's working on, what are some of the challenges that they actually face, and how they're actually using structured streaming and Spark 3.0 at Twilio at scale. So Scott, it's all yours. Share with us and let us know.
Awesome. All right, let me just go ahead and share this guy. All right, let's go to full screen. So my name is Scott Haynes. I'm senior principal software engineer at a company called Twilio. And what I'm going to talk about today, Jules already talked about what I'm talking about, but it's basically building structured streaming based microservices and what that actually looks like. So we're going to actually take a look at gRPC. We're looking at data structures. We're looking at protobuf as well. And then we're going to kind of go through basically like an end-to-end like reliable data system. So without further ado, this is more about me. So I work at Twilio. For people who don't know about Twilio, it's a telecommunications company, and now we own a bunch of different, different data companies as well. We just bought Segment, which is also another kind of hosted data company as well. But we were basically really known well for like telephony. So if you ever get into like an Uber or a Lyft, back when people got into Uber and Lyfts, when we actually could go outside and see people. Anytime you get a call from any of the drivers for going to pick you up, like, on the other side of a street, all that stuff is done through Twilio itself. So I got started at Twilio after Yahoo, went from basically streaming systems at Yahoo, which was running off of like Apache Storm back in the day when Apache Storm was there kind of before Spark, and then switched into Spark once getting into Twilio. So I run a bi-weekly Spark office hours, where I basically just offer internal training to different teams around the company, and also get to kind of like, hijack, good and bad ideas from them as well. And also just figure out like, what is it that, people kind of run into problem-wise, like across the board, whether it's, from, latency or dropped records or, issues with watermarking, et cetera. Another shameless plug, I guess, for me, last year I wrote my first like kind of small book. It was a report on basically operational analytics for O'Reilly. It's not really available anywhere other than like on O'Reilly online, but take a look at it if you want. It goes into basically building up data systems and data platforms, across kind of, new technologies and things like that as well. All right, so where I work. So I work at Twilio, as I said before. The team that I work on is called Voice Insights, and Voice Insights basically kind of started off as like an internal observability tool for all of the data, encapsulating all of the voice, minutes and seconds within our kind of entire global edge-to-edge network. The interesting thing about Voice Insights itself is that we do things on kind of a massive global scale, and when we were kind of starting off trying to figure out like what could actually scale. That was when we started basically using Spark, and we started off with actually like back in the day, like the old like the D streams or discretized streams from back in the day. This was in 2016 on Spark 1.6. So we basically like after kind of going live with like the kind of the original like RDB's API, things worked well, they scaled well, but we still as a team kind of really got into Spark kind of heavily at like Spark 2. So like with the introduction of like data frames and data sets, like it kind of made our lives easier. We also got to basically leverage like the performance optimizations within like the Catalyst optimizer in Spark as well, which is really great. So it allows us to basically offer like our internal and external customers eyes and ears into exactly what's happening, down to like the live call that they're making, and then kind of bubbling back out to the filterable metrics across like everything that they have within their telephony. One thing that I like to always kind of talk about is like the scale that we work at. So as a team, like we're handling millions of events a second. This is also global. And aside from like Spark, I know like Jacek brought up Flink before. I know there's a bunch of different systems for doing stream processing, but for us, like Spark was one of the things that could actually allow us to kind of handle the scale that we had in a global way. In which we weren't just going to kind of keep on tipping over. So being able to kind of scale it horizontally allowed us to be able to enable like really interesting things without just sitting there kind of operating and figuring out how to kind of make it to like, I don't know, Black Friday or, make it to, some kind of holiday or anything else like that. So instead of sitting there kind of always working on tech debt and always figuring out how to, get, make it through the week, make it through on call, we got to instead, work on Spark, which is really, really fun. So there's a joke on my team. Whenever I get to talk about things, I usually just start to kind of go off into, starting off with, here's an idea, and then kind of quickly kind of drilling down into, the nitty gritty of, the very kind of like the internals and everything else of why something actually works. So product manager, shout out to MC, created this slide. So every time I want to basically go start talking about something, I have this nice, like, just real quick, let me talk about this. I'm going to talk your ear off for like the next hour and a half or so. But in that case, what I want to talk about right now is actually what it looks like to actually build up something that actually enables like, true kind of streaming 24/7, 365, like, every second of the day, like reliable data. I know that a lot of people like across all the talks, like from, this current Spark Summit, last Spark Summit, really ever since like I started kind of getting into Spark early on, there's always this question of like, how do you know that your data is accurate? How do you ensure that, that is reliable? And, how do you handle corruption and anything else like within like your data? So that's what I'm going to kind of go over now is, what does it look like to actually build that, reliable data architecture, and also one that actually handles kind of an end-to-end streaming like data infrastructure as well. So without further ado, this is kind of piggybacking off of a earlier talk that I did at Spark Summit earlier in the year. So I'm going to go into kind of more of the details of like the, the different pieces of the component architecture. But what I'm going to talk about first is basically this left-hand side. So we have gRPC, which is a generic or, Google remote procedure call library that works across a bunch of different languages, from Scala and Java to Python to Go, et cetera. And basically why that is that, why does that work and why does that help us, be reliable? And primarily, why does like protobuf help us be reliable like across the board? So we're going to talk about how protobuf can be used kind of end to end as well. So from actually, generating, creating the initial data structures that encapsulate, the events or that, micro story about what's occurring like, within a system. And then basically taking that all the way through to, from client to gRPC server. And then, basically from, production into Kafka, and then from Kafka into Spark, and then from Spark elsewhere. So we're starting off basically with the basics. So strong and reliable data starts at ingest. People always talk about ingest, and you have ingest at the API gateway. So if you think about microservices architectures, or microservices in general, you have a service that does something. In this case, we have a service that is dedicated to, data regarding, telephony. So in the case that we're going to walk through right now, we're talking about call events. So events, in the case of, I have a phone, my phone is ringing, I'm going to pick that up, I want to enter into a call. Like there's a lot of different states that occur like within like an actual conversation, basically from start to finish. And a lot of that information helps to, not only bill for like minutes of like phone calls, but also to understand like when do things go wrong. And being able to, understand when things go wrong is difficult if you don't know exactly what it is that you're encapsulating from a data structure point of view. So when we start with, when we talk about structured data, we basically, a lot of people always kind of start to talk about JSON. JSON, was kind of, the bread and butter of, kind of like RESTful APIs. And it's, was a very interoperable structure that worked with any language, given kind of the simplicity of, how you could describe that object itself and then convert it into any other language. But JSON itself, although people love it, has problems. And the problems are that you can't actually ensure that things are actually being written across the board correctly unless you throw in a bunch of different guardrails across the board. So if somebody decides that, they're going to write a new version of like a schema for that JSON, if that's not published all the way across the board, there's no way of really enforcing that unless you have really good kind of upfront, validations and everything else. But aside from that too, JSON has like a kind of high overhead in terms of like bandwidth transfer. So, if you think about, the cost of, sending data across the board, if you think about the cost of millions of events a second, things start to kind of add up. So, switching to that binary format always makes a lot more sense, not just like within Kafka, not just within Spark, but also like across the board. So we talk about protocol buffers. Protocol buffers feel like JSON. If you're familiar with like the Parquet format, it's going to feel very similar to Parquet as well. You basically have messages. So the messages themselves are a structure, and the structure encapsulates an event. In this case, we have a call event. It's basically, a summarized version of what we actually have within like our internal stack, so it can fit on the slide itself. But if you think about it, Jules was talking earlier about people discussing data and discussing data stories, or even just stories about like what is it that encapsulates like something. In this case, if you think about what do I want to do with my data, and how do I want to ensure that like moving forward I'm able to actually rely on that data. A lot of that kind of there is an upfront use case in designing data and designing what it is that structure is going to be. So with protobuf, it allows us to create something that can be compiled down into kind of any language that we support. Twilio used to be just like a kind of Java JVM shop, switched into Python, SendGrid, which we purchased like 2 years ago. They use Go for a lot of services. So now we're kind of this like polyglot in terms of like the different languages that we use across the board. So being able to have something that's interoperable across the different stacks is always like a good thing to have as well. So relying on Google to keep on making this thing work well, and that's that. So one of the things I talk about too about just like the data itself. So given you have the ability to kind of compile down these proto files, and we're going to take a look at those in just a second, it allows you to actually version the data that's going to actually first get ingested into your API gateways, and then also enqueued into Kafka itself as well. And because you kind of have these end-to-end guarantees in terms of what it is that you're actually sending across the wire, it actually saves a lot of kind of corruption downstream. So if you think about it, it's better to be able to stop bad data, literally at the source, than it is to actually try and figure out where data got corrupted, like within, a single data pipeline, or within like, an entire kind of data fabric or anything else as well. So starting off and ensuring that things are, valid up front always makes things a lot better kind of down the line. So that's one of the things that like I had learned at Yahoo, and I took into Twilio when I came to Twilio as well. And that's something that our team has basically kind of proved is very successful like over time, because we don't really have problems in terms of like corrupt data. We have different problems that I can get into at the end where, it's more about when things go wrong in the pipeline, or if things get backed up and things like that, like, are we outside of, specific SLAs? But like data hasn't been one of those things where it's like problematic. So we're not getting like end of wire exceptions or anything else, which is always kind of good. So one of the takeaways is basically that, between releases, people really like it when things continue to work. And, if you can guarantee that things, continue to work from like a, basically a messaging format within like your microservices, then you don't have to really worry about whether or not you're going to break downstreams, or if upstreams are going to play nicely with downstreams, et cetera. Instead, you can just, publish your specifications and kind of go from there. The other nice thing too is that these protocol buffers also play nice with gRPC. So when we started off, we were just doing basically protobuf across like the wire, and using a library that Google created that's basically JSON protobuf. That allows you to kind of serialize from JSON format into the actual protobuf definition using basically JSON. But gRPC allows you to kind of stay binary across the board, which is really nice because there's no kind of transformation or any kind of problematic data being sent accidentally. So people like it when things work between releases. Also, people like having kind of guardrails in place. At least I do, because it helps me sleep at night. So I make this point: the data engineers love gRPC, and I have this note that it's a caveat because it's not actually technically universally accepted, but I believe it, and other people that I work with also believe it as well. The reasons for that is that gRPC actually saves you a lot of time. And we're going to look at that in just a second about how time is actually saved. And usually time is saved because you have a pattern that can be repeated and basically automated, versus having every engineer always continue to do the same things over and over and over again. So in this case, time is money. People like saving money. That's always kind of good, in general as well. So gRPC, basically in a nutshell, is it's an RPC, which is a remote procedure call. For people who haven't heard of RPCs before, because it used to be kind of like an old school thing before REST, and now it's kind of coming back, into kind of, the forefront again. Like RPC itself allows you to basically, it's kind of like an SDK, it feels like. So your client basically is running code directly on a server, but everything feels like it's being done on the client. So if you have the ability to kind of compile down these client, let's just call them SDKs, from like a general format, it actually makes it really easy to be able to, create, version releases across the board from any of the clients that are, interoperating with your actual, data formats. It just helps to save time, which we're going to see in just a sec as well. But I make a point that it's also great for internal services. One of the reasons why gRPC is not necessarily as great for external services is that not everybody is going to basically want to work with gRPC itself, because you're basically sending binary data across the wire. So a lot of companies have basically put up kind of gateways to be able to take their data, convert it once it gets internal, like within their VPC, into a format that is, lighter weight. So if you think about kind of like end-to-end, like internal, data transfer, that would be basically, so from on the screen on the right, so gRPC client can exist within like the intranet or it can be external. But once everything kind of gets internally, everything's basically kind of end-to-end binary. And that helps, that basically helps to ensure that there's stability like across the board, and that people don't have to continue to write like the same services that, create a server, et cetera. Instead, you can basically compile down both your messages and your services. And then you can also create like, so let's say like 40 to 50% of the actual stub code to actually run your individual services as well. So in this case, let's take a look at building actually a call event service. So for a call event, when we took a look at the earlier kind of protobuf definition itself, we have an identifier. In Twilio nomenclature, we call it a call SID, which encapsulates like a call leg, which is like, Alice calling Bob, or in my case, like me calling somebody else. We have an account, we've got durations for how long the call, how long did the event occur for? If it's a call, it's going to have a certain amount of time, and then different states. So this enumeration I have in here is actually kind of small enumeration. What we actually have internally is a lot larger than like what I'm actually showing here. This also fits on the slide. So this information, it's right here, gives us an understanding of basically Unix event time, region in which something occurred, in this case call event, then actually the state of the event, and then other information encapsulating that event itself. We also have these services. So if you've ever had to write any kind of like API service or anything else like in the past, if you could instead basically write just like this, like this interface definition right over here, it makes it a lot easier, because you can say, okay, I want to create the service. The service is going to basically have two different methods that I'm going to expose. And then I can basically just do SBT, clean, compile, package, publish, local to basically get an example of everything kind of locally for myself. So Scala PB we use on the team as well. That allows us to basically take those service definitions and compile things down that are Scala friendly. So here's an example of basically running a service. For people who've run Spark services before, you've got an await termination, we've got some starts, we've got some builders. Like it's fairly kind of similar in terms of kind of the feeling of everything else. Like it, or if you've basically done Scala services before, it feels very Scala-esque. But yeah, so this is basically just an example of what a gRPC server looks like. A client itself is basically a couple more lines to be able to kind of generate that, that actual stub itself. And behind the scenes, it's basically using a pluggable Netty interface to be able to send the serialized binary data, which encapsulates our protobuf messages, basically from our client to our server. But most of the stuff can be done like the stub code itself can be done in a few lines of like Scala, a few lines of Go. And then you're just implementing things like you would, in any other kind of, server-side API or any other kind of API. But in this case, everything can be versioned. So from the actual protobuf to the actual services and the services themselves, which is great. So what we basically see is that there's a common kind of pattern that emerges across the board. So if you have the ability to basically, create a message definition, you have the ability to create a service definition itself, And then you have the ability to kind of scaffold these kind of microservices directly from, a compiler. It allows you to kind of quickly iterate on, almost like, individual SDKs for your different, different data, data structures that you need within like your data fabric. So if we think about data engineering in general, you're either, pulling stuff directly from like, databases, you're pulling stuff from Kafka, or you're taking stuff directly off the APIs as well. So in this case, if we are, receiving events and we're ingesting those events, this allows us to kind of create that, an end-to-end definition of what that ends up looking like. And then we're basically filling in the blanks with, minor amount of like, library code, but everything, between releases allows us to not have to worry about whether or not it's going to work in general across the board. Did it work before? As long as we have everything tested correctly, then it's going to continue to work, between releases and everything. So that's basically the kind of the ingress pattern right over here. So what we had over on the left-hand side was basically what we just looked at was basically client, through a, API proxy, in this case, Envoy with authentication, into the actual gRPC servers. And the gRPC server itself is responsible for then, putting data into Kafka. But we're sending protobuf messages from our gRPC client to the server. The gRPC message itself extracts out, the individual protobuf that encapsulates, say, a call event, like we're looking at here. And then that call information is then enqueued into our Kafka. So we take a look a little bit at now the Kafka to protobuf to Spark interaction itself. So for the call events itself, we have these call SIDs. The call SIDs encapsulate a call that's, active, or it's been completed, or it's, inactive because it failed to start. But there's a lot of different events that occur along the lineage of that individual call. And because we have, so let's say we have a limited number of events per call that fit nicely into individual partitions if we want to be able to, read that data into Spark itself without having to worry about, shuffling off of like random like UUIDs or anything else. It allows us to have a good partitioning key. So without kind of going too much into, the Kafka weeds, Kafka handles synchronicity amongst the topic partition. And so if you have events that are coming in over time, and time is important to you, then being able to have events that should be co-located together within time is one of the things that Kafka is really good at. And so in our case, we have these call SIDs that are basically stamped, with their UTC timestamp, both, at the client itself, but also at the server side when we actually receive it as well. So we understand basically what's the delay between, when an event was actually created to the time that event was actually received, so we can understand lag and other metrics like that. That could be an entire talk on its own. But in the case of having call events topic with partitioning keys by call SID, it allows us to then basically hash partition across the board to be able to reliably have an entire stream of call events that we can then feed directly into Spark. And remember, those call events are all in protobuf format. So now we're getting into basically some Spark code. So the Scala PB library has a plugin that's basically Scala PB, and it's Scala PB for Spark SQL. And so what the Spark SQL library does from Scala PB is it basically creates these internal encoders. So inside of Spark itself, you basically have the ability to take binary data that is typed with a schema, and that data ends up becoming what's known as basically like it's a catalyst data row. And the catalyst data row inside of Spark SQL doesn't necessarily handle protobuf outside of the box. But by using basically the Spark Proto SQL library, you can actually interrupt directly with protobuf within your actual Spark applications. So what we have right here on the right-hand side is just kind of showing like a very basic, like, if I wanted to do everything and test it inside of Spark to ensure that the producer data that's being produced like from the gRPC side is also going to work, and I want to test like an end-to-end flow, then all that stuff can also be tested like directly in Spark itself. So on the right, we have all of our published data, which is like our call events, and these are just kind of random kind of junk data just to test that things are working. But all we do at this point is we basically use the ProtoSQL data frame creator that plugs the Spark session, and then it also plugs the sequence of these call events. So behind the scenes, what's actually happening is that it's encoding that protobuf data into that catalyst row, which ends up becoming basically a data set. And from there, that information is actually just encoded out into a Kafka data row. And so it's using Kafka data frame to be able to actually publish out, in this case, to a local Kafka server that I have running in local Kubernetes. So just kind of showing like an end-to-end, like we have now binary data sitting inside of like our, inside of our local Kafka. But behind the scenes, what's actually happening is a lot more kind of interesting. So we have this proto-SQL and we're creating this data frame and we're throwing in basically our Spark session as like a reference over there. So using kind of a dependency injection pattern. And then we're basically throwing in like our, kind of our typical, just like, our sequence of data. So when we're using the as call event, we're actually using an implicit typed encoder. So the nice thing about the typed encoder is that we don't have to really worry about casting across the board. So everything actually knows exactly like what its type should be. And there's kind of a guarantee on the type that's actually going to be extracted from the protobuf. So it saves you time in terms of not having to kind of cast everything from like a, an untyped row or untyped column into an actual typed object itself, given that we know that there's no way that something can be different than what's actually specified within the protobuf itself. So what I have over here is basically just kind of showing what that example ends up looking like. So, what are these encoders? What do they actually mean? How are they being created? So here is basically kind of showing an example going from proto-SQL data frame, basically creating a conversion to our Kafka data row, and then actually using like the encoders.product to create like a Scala case class encoding of our Kafka data, which allows us to then write into basically write into our Kafka topic using just like the internal kind of Spark data source Kafka writer. All right, so now that we've have something written to kind of like the local Kafka or whatever else, we now have to if we might want to read all that information back again. So over here on the right hand side, I have basically a Spark reader. That's just basically reading from the Kubernetes Kafka that I have running locally as well, subscribing to the topic where I just wrote everything. And all this is doing is just kind of showing that protobuf data was encoded and basically stored inside the value within our Kafka row. And now when we're reading that information back again, we can select back out that value and basically deserialize that back into the individual like catalyst row again. So we're basically using the kind of compact protobuf binary as things are basically being sent across the wire. And then everything's basically being converted back into the catalyst row as well, so that Spark can actually optimize further once the data is actually loaded into memory. And so, yeah, from here over here, this is basically just part of a unit test that I was doing to kind of ensure that, I could kind of present this without having to, like Jacek was doing as well, not having to actually show like internal code from my company as well. But over here, it's basically, I wrote, these three kind of sample events, and then we read back the three sample events, and then we have this this data frame written back into like a temporary table as well called calls. So then from there, like within like the actual unit test itself, we can actually do manipulations and tests, or even test kind of complex aggregations without having to do too much in terms of testing like Chuck Norris in production or testing outside of even like a local environment. So it allows us to do a lot of kind of gut checking early on, fix a lot of serialization errors and anything else like that prior to things actually even making into code review, which is a kind of really awesome pattern to be able to follow. So far, we basically talked about the gRPC pattern. We talked a little bit about protobuf, how it's better, in my opinion, than JSON. It's not as easy to work with as JSON, but it allows you to ensure that if you have streaming applications that are up and running, that you're not changing things in a non-backwards compatible way, because that stuff is basically being written directly into the contract for both your messages and also for your gRPC services. We talked about choosing a partitioning key to be able to hash partition into Kafka and then basically read that data back in from Spark itself. So once we're in Spark, we just took a look at kind of a simple way of being able to test, kind of locally, like in a memory stream, what it is that we're actually working with once things have been deserialized from Kafka back into individual, catalyst row of that call event, just a data frame over here. But once once that stuff has been read back from Kafka itself, there's a lot more that we can actually do with it. So in the next step, I'm going to talk about basically taking that same data and then actually writing it out as a Delta table. And then we can talk more about kind of, what does that actually entail? Like, or what does that actually, achieve in terms of, enabling, downstream Spark applications or downstream other services to be able to, work with the data that was kind of fed from, this data pipeline. So I call this part basically Spark and Friends. So we talked before about the proto to catalyst data frame. So here I have basically another read stream. So we're creating a data stream reader that's attached to our, in this case, our local Kafka. It could be any Kafka as well. So we have our Bootstrap services. We're subscribing back to our topic again. And I'm just adding a couple more Kafka options as well to be able to kind of fetch more information in each individual pass, so that I can actually, in this case, I'm basically taking up to 6 million records. And so where we have like the fetch offsets per trigger, taking 6 million records per batch, given that we're doing like 1 million, events a second, it's not necessarily a small, it's basically 6 seconds covered for each individual batch. But aside from that, once everything's actually been kind of pulled off of Kafka, we're now basically just doing kind of a simple conversion to be able to extract out our time. So we have the event time. Event time is our UTC timestamp. So in this case, all we're doing is basically preparing the data to become kind of our raw data inside of like Delta Lake, or raw data inside of Parquet and HDFS, depending on what your choice ends up being for how you want to work with your data. But in this case, I don't have a pointer, but we scroll down. So we basically create our reader. Our reader is now assigned to subscribe from our Kafka topic. We load that into our call events data frame. And then from there, we're basically generating like a streaming query. So the query itself is just kind of going through the same exact thing we did before, where we're saying, okay, well, I want to select out the value. Like we already know the topic that we're subscribed to. I don't necessarily care about the key in this case because the partition where the value is coming from is going to be guaranteed to be keyed by the underlying call SID. And the call SID itself also exists within the row, so I don't really have to do much with it in this case. There's really interesting things you can always do, with the information provided by the Kafka data frame. Be it taking the information from like the Kafka headers or taking topic information or timestamp information. But in this case, all that stuff is encoded directly into the data within our call events. So we don't have to actually worry too much about that. So as a simple example, we get our call events. We're selecting our value. We're calling our flat map. In this case, it's a row to call event. I'm going to show what that method looks like in just a second. But the flat map itself allows us to, in this case, handle corrupt data. When I was working locally, I was basically just testing kind of a bit different use case, but I was testing kind of a end-to-end example running like in like a local Kubernetes. And I was testing just like local, pub sub with the Kafka client. So I had some kind of garbage data prior to actually adding binary protobuf into the topic. So in that case, I had data that wasn't actually matching the value of the protobuf. So in this case, the flat map allows me to kind of get through like the garbage data that I put in there. In production, that's basically the safeguards that are in place by the gRPC system itself. But locally, when you're kind of messing around with things like, you can always, you can basically always screw stuff up. So anyways, this basically takes the value, extracts out the call event itself. Then it adds a kind of a temporary column to the data frame called date time. So we're taking our Unix timestamp, which is our epoch milliseconds. We're now converting it to seconds, so we can convert it to the Unix time date time stamp. And then that's in basically the row for our date time. And then we're actually using the Spark function to just kind of cast the date time back to date. So we can create a partitioning key that's by date. So that partition key ends up looking like 2020, 11/18. And then all we're doing at that point is basically creating a partition for each individual date. We're doing append only within like our Delta table. And this one's doing like an auto merge of the actual underlying schema itself. Given that we know the schema is backwards compatible, it allows us to be able to not really worry too much about how those schemas are being merged. But depending on how things are actually being done outside of, depending on how things are actually being done, like by, whether it's other teams or anything else that can't be like automated, then, you have to be a little bit more defensive about how you merge schemas in order to ensure that the underlying, data doesn't actually get corrupted. But in this case, it's safe. And so we can actually go and write all of our data back to our Delta table. So what that ends up looking like running this entire operation is that we read in our 6 million records. In this case, we're basically partitioning over, it's not really defined here, but if you had, say, if you had the 6 million records and those are across, say, 20 partitions, and you'd have 20 individual partitions because things hadn't been repartitioned. But every time the system ticks, you'd end up getting, 20 more files. So that's another thing to kind of think about too. So how often are you actually writing? Because the total number of files written that are backing the underlying like Delta table, or in this case, like, the net total number of files backing your individual like table, there's a cost to that. So you can basically optimize that with Delta, like through additional operations, which they're going to talk about tomorrow in a little bit more detail at the next meetup. But if you're able to basically go optimize and kind of squash data back down again, so you're fixing kind of the small files problem, this isn't that much of an issue. When my team first started off, basically writing things, it was basically just raw Parquet and it's writing to HDFS. We ran into an issue where we were ticking even like every 30 minutes, and we were creating, I think it was about 50,000, 64,000 files like a day. And then we were having to basically squash those back down so that we could have not as many open files like at any given point to actually read like data that encapsulated like a day of, say, like call events, like, call events are just like calls in general, like at Twilio. And kind of prior to being able to, auto-optimize those, without being able to auto-optimize those, like there's a lot more kind of problems in terms of, how do we reliably ensure that we have, the same data that's not kind of going into like an underscore temporary type situation, that's not being like replaced when somebody else could actually be reading it, which is there's a lot of problems with that in terms of being able to have like a file system that's, open for read and open for write at the same exact time. So without going into too much more detail, because I don't have a good like visual within like this this presentation, it's really nice to be able to just say like, I want to partition by date. I want to do append only. And now I'm going to go through and just kind of continue to write to my, individual, partition by date, partition by number of partitions per date, like file system, encapsulating like the backing table for an individual, Delta table. Actually makes things a lot easier to be able to do that. So, all right. So what we've looked at so far, I know there's a lot to cover within like the kind of short time that we have together. But kind of the high level stuff. Yep.
Sorry, you got 5 minutes if you don't mind.
Oh no, that's perfect. I'm wrapping up right now. So I can make it within the 5 minute range. Perfect. Okay. So basically I talk about this rinse and repeat pattern. So far we've taken a look at, defining data structures, creating protobuf messages to encapsulate what those data structures are. Those data structures encapsulate, kind of known events. So instead of writing a, API or anything else that's, literally only writing to like MySQL for like a very specific, like, user-facing API kind of point of view, this information is actually encapsulating, either operational metrics or, events of interest within our individual kind of data, data flows from a kind of data specific point of view. For, in our case, it was operational metrics, and then it kind of extended out to, business intelligence and other things like that. But defining the data up front made things really, really good in terms of being able to rely on what it was that, being able to rely on the actual data that we're passing into our system itself. So what is a question that we want to answer, and how do we do that? And how do we sorry, how do we emit that within, kind of the smallest event possible? And also, how does that event itself join with our other events and able to, create, in the case of like sessionization, all call events are basically, reordered over time. And we have a definition of exactly what occurred within a call, like in real time, with basically update stream the entire time. So as more information becomes available, we have a fuller and fuller record of what's occurring within a call, until the point where we actually close books and our call is over. And so if you think about Spark and state machines and things like that, it allows us to be able to define what those individual kind of flows are over time, to be able to do difficult things with our data in a way that's really manageable. And so what I have over here is basically kind of moving from a more kind of simplistic, we have one event and it's being emitted into our system and that's being put into a single Kafka topic, going into a system where now we have, information that's being passed into the Kafka, and then it's basically being, sent between different Spark applications themselves. And the Spark applications are then writing, intermediary records into like a Hadoop as well, to be able to, kind of keep up to date with exactly what the point in time status of our entire system is, with different kind of avenues for taking that data and then presenting it, whether it's through, analytics dashboards or, it's being, emitted into a different system like a Presto, or, just basically being emitted back out, to another Kafka, or even sent off to, a downstream customer through like an event stream. So I guess I probably have like a minute left. And so in general, Spark allowed us to easily scale to handle millions of events per second in a way that made it feel like we were writing things locally on our laptop. And scale itself was, the scale itself of the entire system was something that we didn't have to spend a ton of time on, because we were using Spark and it was able to scale because other people were working on it and other people had also solved the problems that we were currently encountering. So it's really easy to go online, find answers when we had questions, and then from there dig in where we had to, like into the source code, to ensure that things were working well. So that's pretty much it. It's my whirlwind meetup talk on kind of end-to-end gRPC protobuf streaming architecture. And thank you. That's it.
Well, thanks a lot, Scott. I think that was a really insightful presentation of giving us really an end-to-end pipeline of how the different components work together, not only about a gRPC, but how you actually do with partitioning with Kafka, and then how you're actually using the adaptive query execution to make sure that when you're actually doing the joins, it adapts very well with you. So how much of that has already been upgraded to Spark 3.0 and how much is still running bits of in 2.x?
I like that question. So right now we've been moving a lot of tests to 3.0.1. Mm-hmm. And the reason for that is probably the same kind of reason that Jacek was having the problems with like Cloudera's internal Spark. Mm-hmm. We wrote our own like protobuf 2 encoder. And so upgrading everything from proto 2 to 3 wasn't as difficult as basically performance tuning and testing somebody else's like expression encoders. Because expression encoders, given it's doing code gen, depending on the size of the messages that you're creating, you can literally create classes in like the Java code gen that are too big to fit in memory because there's too many fields. And so part of that, we had a way of basically filtering out basically included or excluded fields within the protobuf messages in Proto 2. And now moving to Proto 3, we have to basically re-implement that encoder, or just basically we're using right now the Spark PB out of the box. Mm-hmm. But because it's wrapping everything as like inside of a bunch of different case classes, it ends up being a performance overhead in terms of GC when we want to basically do that initial conversion, even after the code gen's been executed. So we're now working more on the performance of that, because some of our like larger protobuf messages have like over 1,000 possible properties within them. And those are kind of like, nested into like individual message types. So it can get really complex in those cases. So you have like code gen where you have, over 100,000 lines of code gen, and it's really hard to go and debug all of that. But anyways, aside from that, basically Q4 has been, Q4 has been a lot of working towards getting everything to actually work and having it all tested, because we ran into a bunch of issues with GC. So that's been Q4 so far, and it's been fun to kind of dig into a lot more. I mean, it's, Catalyst is super fun in general. For people who don't know much about like the optimizer, it can be really squirrely to work with, but it can also be really rewarding to actually get something to work. I think it's one of the things that there's not a lot of really good information if you want to go find resources on that, other than going back and trying to reverse engineer like, the product encoder or like the Java Bean encoders or anything else. So that's really that's where we started before. And that's been, I think, for the team itself, this guy, Merrick, on the team is very, very skilled at the JVM. And he was able to help fix a lot of things with like static invokes and other things that, make things a little bit more optimal. But yeah, so it's been a blast.
Well, lovely. I mean, thanks for sharing all this insightful. And if you have any other issues they're actually having with the experimental versions of some of the features in 3.0, please do let us know so we can actually delegate to the appropriate people. As you know, you are
Awesome.
a big contributor to the Dev Spark group as well. So whenever you put questions, we jump on it right away. There was another question. I think that's for Jacek. I don't know if you answered that, but there's one person was from your demo, why in the second call to the state function that still falls into the condition with 3. I'm not sure what he actually means. You might actually want to read it, but you might want to answer it later. Let's see, I'm going through the quick ones here. Hi, Jacek, which books and GitHub links do you recommend? You probably want to write a Wikipedia for that one. You can probably put those links on that particular question if you don't mind. And then final question I have for Scott. Somebody, my fellow, a person who actually gave a lightning talk, Jung Wook, who is a professor at Cal State University, asks, thanks for sharing. As everybody else is very happy to hear both the presentation. Scott, do you have any prediction area to adopt Spark ML/DL after collecting the message? So in other words, do you have any machine learning code built into the pipeline so that you can actually predict certain aspects of the message? Is that something? Is that something you're considering, or something valid to have?
No, so we have. Yeah, so a guy in our team, Bhargav, he actually wrote a predictive. It's basically predictive analytics on top of like our stateful aggregations, because given that certain events can be dropped because they never came over the wire, to basically encapsulate the fact that like a sessionized session is completed. A lot of times if you say you have 10,000 events that encapsulate a session and you're missing a few events that, basically are key trigger points to when to start dropping state from the state store. He wrote basically a predictive algorithm to ensure that we could start dropping state without basically bloating and, exploding our processes. And that's actually live in production right now. So it saved us from basically waiting for up to 24 hours for state to kind of time out, to being something that could be done within like 6 minutes of like known state and known call being completed. Aside from that, we do like a lot of like collaborative filtering and like statistics work. So kind of more like Bayesian inference on what encapsulates good and bad calls. So you have a notion of like tagging. So it's, a lot of it kind of goes into like network level metrics. So it's like, packet loss metrics and jitter metrics and, any kind of like, out of order packets or like, round trip time type statistics for latency and things like that. We have kind of, it's a global idea of how things look. And then it's also kind of localized to individual like regions, to individual accounts to understand like, is this normal? Is it abnormal? And it's kind of more of, allows us to kind of create waypoints in like a pile of data to be able to, to basically root out problems. So
Well, lovely. I think that's going to be a subject for our next meetup talk, Karen. We should probably book him to give us that particular talk on how they're actually using that to save the messages coming down. Jacek, a question for you. Have you figured out finally the precise types of join used during the merge operation?
Well, honestly, can you hear me, by the way?
Yes, we can.
Okay, good. Okay, so so I'm gonna share my screen because I'm gonna show this part of my internals book where I'm describing this exactly, to answer your question. So, well, I did review some of the code that's used for this, for this part you are asking for. So I know that this is used twice, and this is just common knowledge, I'd say. So I know that there is this inner join or left anti-join based on something like I marked find touched files, or blah, blah, blah. So I'm yet to figure out exactly what are the cases that lead to inner join or left anti-join for the first join, as well as when there is this case for right outer, rather than full outer join for the second pass. I'm yet to go over it again and again. Well, it's not that obvious. There are some tricks that even after 5+ years working with Spark, still take time to to absorb fully and be able to explain it. That was also the case, that the same experience, or the same, not excitement, but feeling I felt after Scott mentioned expression encoder. This is yet another area where I'm lacking skills to explain it clearly. So I knew immediately when Scott mentioned, expression encoders, that he was very close to boundaries of my knowledge of Spark. So that's another case. So yeah, I'm working on it. So yeah.
Another question for you, Scott. I think when I was looking at your slides, Spark plus Friends, there were a couple of places where you're actually outputting the stuff. So once you've actually processed all the data, you've done the ingestion, the protocol buffer have been assimilated into binary, and now you're processing it. Now you're ready to actually write it out. So you're writing it to the Delta table, but you're also writing it to the HDFS. Why are you writing it to Delta table, and what purpose it is actually serve? Can you expound a little bit of more, what are the benefits that you actually saw from writing to the Delta table and not writing elsewhere?
Yeah, so part of it came from I guess an earlier kind of an experimentation from back in like May. So I was working, basically doing some stuff for Redis conference and working on like the Spark Redis to be able to look at Redis streams. And Redis streams themselves are a little bit kind of more complicated because you're sending like a third-party hash buffer into Spark, and then that's being converted back into like a data frame. But being able to work directly in Parquet and then do like a Parquet protocol stream is something that's not really even, it's not necessarily even like a real good option in terms of like, if you think about like, I don't know if actually this is the case, but I haven't seen people putting Parquet directly into Kafka. And so one of the things, being able to actually stream Parquet for me was like a dream, because it makes it a lot more efficient to be able to, reduce down like the set of data to exactly what you want, like, by, doing like, prune filters and things like that. Mm-hmm. But aside from that, like, being able to keep everything, directly like within like, basically off heap, memory, for me is much better, because it also kind of attacks that problem that we do have like with like higher GC, by having, this lineage of a lot of kind of, wrapped case class type instances, so that, that kind of, what's the overhead of like the, the implicitly defined, case classes and things like that, versus being able to just take a look, directly at, rows of, individual selected columns, within like that, that are unbounded row. That in itself, so taking a step back, because I know it's like a harder kind of question to answer. We used to do a lot of stuff with like the file stream sync and the file stream source. And with the file stream source, we ran into issues where, if we created like new directories, we wouldn't automatically pick up from the directory itself. So being able to take a look at, can we do some similar things where we had problems before, like with HDFS and, you know, other issues with like the Spark metadata and things like that? Can that be resolved differently with like Delta? Because Spark metadata is one of those things where it's like, oh, I got rid of my checkpoints. Everything's broken still. Oh yeah, Spark metadata. Why is this thing here if I don't need it for reading, and, you know, vice versa? So being able to kind of reduce some of those issues where, you know, it was basically like, you know, something that kind of, you know, halted, I guess, like the process like in the past, you know, would that be able to allow us to do things kind of differently in the future? Also the idea of being able to, you know, because we have HDFS, which I feel like is something that's like, it's a nice to have in terms of like the multiple reader, you know, multiple writers, I guess, with Delta Lake. So we already have HDFS, so we can do multiple writers. But also from there too, given that you can now create like this, you know, basically the streaming data fabric from, you know, a bunch of different kind of tables from Delta. For me, like, it's like, oh, this is like a really cool thing, because a lot of people are doing Airflow for the same exact thing. But if you don't have to have a bunch of different Airflow operators, and you can actually share that memory. And for me, that's kind of a big win in certain cases, to be able to just use Spark, given that it's a DAG system, to do a lot of stuff that you would have done anyways, but without as much of the go back and read, go back and write. Okay, now on to the next step, go back and read, go back and write, next step. So it's like, if you think about like where Spark came from, you know, MapReduce was doing exactly the same thing of just read and write, but it's like, oh, we can do that better. And then Spark did it better. But then it's like a lot of people are taking it back to what MapReduce did, but they're just using Spark in the middle. So it's like, can we do more to, you know, leverage, you know, kind of more of this kind of, you know, distributed state sharing. Anyways, that's why we're using Delta. So.
Well, thanks a lot. I think I've exhausted all the questions that we have that I can't fathom, but I think we could probably just give back everybody 10 more minutes. It's close to 7:30 in Poland, Warsaw. It's 10 o'clock over here, or 11 o'clock over here, lunchtime, obviously, and we are wide awake like an owl. But I'd like to thank Jacek for staying up so late and sharing your knowledge with all the people who are out here. We have more leaves and more branches in our tree of knowledge. So always nice to have that. And thanks a lot, Scott, for sharing how you guys are actually doing these things at scale at Twilio, and especially sharing some of the stuff that you're actually building, the end-to-end pipeline, and what are some of the different Spark Plus friends that you're actually using, which is a testament to how Spark has evolved over the years in embracing the large ecosystem that allows people to build these end-to-end pipelines. So thank you a lot. And I want to thank, you know, my esteemed host, Karen. And I think Danny has gone into comatose. He's gone to sleep. He's been out since 2 a.m. in the morning. So he has disappeared, but I want to thank him as well for doing all the work. And Karen, thanks a lot for keeping us honest and keeping us on time. Anything else you want to add for tomorrow's keynotes? Hope anybody who is still around, we'll see you tomorrow. We're having another meetup, so hoping to see you again. So thank you very much for everyone. And Karen, you can probably close it off.
Yes, thank you so much. And thank you, Jules, too. Awesome session. Thanks for your time. I'll just echo. Thank you, Scott and Jacek. Yeah, go ahead.
Oh, one more thing. One of the people asked, how are you going to be able to get a PDFs for the presentation? Jacek and Scott, I think I have your PowerPoint, but could you send a PDF version to Karen, and I have Scott's, and we'll figure out how we're going to upload that along with the video in the coming days or so. So thanks a lot.
Sure.
Yep.
C'est la vie. Good night. See you tomorrow.
Thanks so much, everyone. Take care.
Cheers. Bye.
Bye.
Cheers.